Point clouds are getting a lot of attention in self-driving domains. The reason might be that they provide very good data, and that can be produced through LiDARs as well as depth cameras. So both of these can produce point clouds, and we are going to be learning how to process them, how to make them in simulation, how to work upon them using PCL library in C++ with the help of ROS2 as well. But if you just want to learn point cloud processing, this will work for you as well. Just skip the ROS part and you can process the point clouds. To just start off, we are going to just only focus on three things: installation of the library and the RTAB map to produce the map, and Turtlebot 3 simulation. So for installation, you are just going to copy this command and paste it here, provide the password in Linux. That's it, PCL is going to be installed. Coming to the next part, when we are going to be making the point clouds, we are going to be needing RTAB map ROS and Turtlebot 3 simulation. So these two are going to be required to produce the map, but I have made things easy for you. Let me show you a repository of my own ROS2 learners, and you can just clone it. Turtlebot 3 simulation is already there. RTAB map should be installed. I'll show you, and point cloud perception package is already there. You can start developing upon them. After the lectures, all of the codes are going to be uploaded into this repository. The main thing is, when setting up RTAB map ROS, Turtlebot 3 was not working. I made some changes, so that's why I uploaded into my own repository according to the needs of this point cloud creation. Coming to the VS Code, we have this package already created. I am going to first install RTAB map to produce a point cloud. Then we can utilize any point cloud and process it. So for that, just two simple commands: sudo apt get install ROS Humble. Specifically, we are working with Humble. RTAB map, this package already installed, and another package RTAB map ROS. Press enter, and I already have that as well. These two I will be providing the links: RTAB map ROS and RTAB. These are the most important packages that we need. Another one might be helpful if there is something similar for PCL. Let's see, PCL. Yes, there is PCL messages, PCL conversion. They are available. Let's install those as well, but I don't find any use case right now, but we might need in the future PCL ROS as well. These two are going to be installed. And coming to the point, PCL conversion is also very useful. Let's install that one. I have all of these. Okay, coming to the point, this package is ready for you to start developing upon it. Let's first see how we can produce a point cloud using RTAB and Turtlebot 3. Then we will start testing if PCL is working on our system or not. Okay, so here if we take a look at RTAB map ROS, although the package is installed, we can run it with Turtlebot 3. If I just export the model that I want to use, in our scenario we are only going to be using Waffle because I've made changes in the Waffle model, okay, not the Waffle Pi. Let's bring up the terminal, export the model, and I am going to bring up a simulation that is bringing the Turtlebot and the environment around it. So you can see this is the Turtlebot and the Turtle World, very popular simulation. I can drive the robot inside of here, but we are only interested in producing point cloud of it. So our simulation is running. In the next terminal, there are some documentation that you can follow, but I'll help you in that as well. I have already written a launch file that is going to create a 3D map for you. And to utilize that launch file, once you have downloaded the package from this GitHub repository that I will provide you, and you can build it, and then you can directly run ROS2 launch, and the name of the package is point cloud. The launch file name is 3D depth mapping. Press enter, and it is going to bring up RTAB and its visualizer. You can see here what the robot is looking at, and we can open another terminal to start driving the robot. ROS2 run teleop twist keyboard, a package that sends command velocities. And let's put everything side by side, gazebo side by side, and the terminal that is driving the robot. Let me put it here, pressing I to move the robot. You can see the robot is moving in the simulation, and it is causing the RTAB map to perform 3D mapping, and you can see some sort of images are produced in RTAB map. Yes, and let me just show you by completing one simple image. I will not be spending a lot of time driving this robot, but just to give you an example how you can create your own map. So I moved the robot with the help of depth camera, it was able to capture this information. These are actual point clouds. If I zoom in, you can see dots. These dots are actually points, and this whole area with points is known as point clouds. The basic definition of point clouds is this. So the main question is, how can I utilize it? How it is going to be processed? We are not going to be running again and again these launch files and making small image. We are going to produce a map and then save it as a point cloud and then utilize PCL to process it again and again, because it is a tedious process. It takes time. So once we have spent some time creating it, we can then easily utilize the pre-made point cloud of our own. We can delete this map and produce it for other environments as well. So if I want to save this point cloud, I'm just going to pause it and I'm going to go into export 3D point cloud, and here there are some properties that I will not change right now. I'm just going to say save it, and it is going to save the point cloud. And now it is going to ask me where I want to save, PLY or PCD, or there was another type that you can utilize. I'm going to save it here on the home directory. Just save it, and it has produced it. Close. Now we have the point cloud. We need to move to the next step of this lecture, the last step, that is to make PCL work with ROS, or we can just utilize PCL standalone and process the point cloud that we created. Let's close all of this, close the simulation as well. To integrate PCL into ROS, let's create a script and name it to be test node.cpp. In this node, we are going to be creating a basic structure of C++ code, which is going to be int main and returning 0. We can make it a proper ROS node, but I'm not going to do that right now. We are just going to create a PCL node that is going to be utilizing CMake list and compiling. We are not going to be using any ROS client library, not even ROS C++, and we are just going to be producing a C++ file that is going to be including PCL but built under ROS system. For that, we just need to check if we are successfully able to include PCL or not. So I'm going to say PCL, inside of PCL, let's go for filters and let's go for boost.h, just including it to see if it is able to find the headers or not. As it's a C++ node, we have to mention it in CMake list. I'm just going through it for once, but obviously when you are going to get the code, you will not be required to do this. So I want to add a package that is PCL, that is required. The next thing is to make the script executable. So this is a publisher subscriber example of C++. I'm directly going to go into CMake list additions. So first it performs the addition of the packages. We are not using both of these, that's why we are not using that. The next step is add executable and target dependencies. Let me add that here. And the last step is to install the targets. So I'll copy all of it and just going to paste it here. Coming to the point that what is going to be the name of our file, it is going to be test node. The name of the file is test node.cpp. You are going to be using test node and connecting RCL, CPP and standard messages. Currently we don't need these two because we are not using any ROS interface, but we are using PCL. Here you can see I have these two dependencies, but we are not going to be using that. We are going to be requiring some PCL libraries. You need to understand this, because if you want to create your own point cloud processing nodes, you have to understand the CMake list arrangement, including of the header files. I'm going to get help from PCL library itself. This was the CMake list help. Now let's go to PCL walkthrough. In the PCL walkthrough of point cloud library, its own documentation, let's go to the filters and go to the tutorials. In tutorials, let's just open the first tutorial we get, voxel grid. Here you can see an example code is present, as well as the CMake compiling and running CMake list related things are also present. What I am first going to do, I am going to include these into my file in the test node, or let's bring all of the code and paste it here. Let me remove the numbers. The errors are gone. Let's utilize this code. It is actually reading one file and performing something. Let's not get into it right now. So we have cloud.ply here. So I'm going to say in home Lukman and cloud.ply. There's a file that you can process. Main thing of our interest right now is to compile this code. Going to CMake list at this specific point, if I just included PCL required find package, we have just included it with the just find package included PCL required. So we have just added one package PCL and we are saying it is required. We just need to tell the targets are test node only. We don't have any listener. Now let's perform call can build. And this is our first error. It says no such file or directory is provided. The problem is for CMake list, we have to provide the proper path to the header files, and for that we will be using the help from PCL, its own documentation. It says that you need to include these directories, and then it is going to be able to find required headers. Include directories, link directories, add definitions. And whenever you are producing an executable to an executable, you are going to attach the PCL library. If this works, eminent target dependencies. Otherwise, we are going to use target link dependencies. It's upon our choice. Performing call can build, and PCL common is not found. That is because eminent target is not able to find it, but we can still utilize target link libraries. This is a bigger concept for CMake list, but I don't want to get into that right now. Now I have to check if my node is completely compiled. ROS2 run. Name of the package was Point Cloud Perception. Pressing double tap, there is a test node. Let's run it and see. So no points to read, point cloud before, filtering 0 data point something. That means that this whole code was executed. So it was compiled and it was executed. So now that you can compile your point cloud library code, which is tedious as a lot of headers are included and a lot of things that you need to do in CMake list, but that's a one-time process. So 2 lines and 1 in install tag. The main point is our setup is done. We can produce our own custom point cloud as I have just explained you, and I will write the readme file in a way that you can produce, read it and perform it with all the commands and the links. The second is your one single node with point cloud library included is compiled, so you can make changes, add more content into it with the help of PCL tutorials. From the next lecture we are going to be working on point cloud segmentations and point cloud filtration, voxel grades and all that amazing stuff that is coming, so stay tuned.